Hey guys, Mr. Bowman here. Today's learning objective is in red. We are learning to use Venn diagrams to calculate the probability of given events. The first thing I did when I was reviewing stuff for this video, I wondered where the heck the word Venn came from. And then when I Googled it, Venn came from the guy, John Venn. He invented these diagrams. He was a bit of a logic person, a bit of a philosopher in the dates throughout his life, and they've got them there. So I guess the first thing to note is Venn diagrams are really similar to two-way tables. So Venn diagrams similar to two-way tables. And I'll give us an example to show that. So hopefully you remember your two-way table stuff. You had variable 1, variable 2. Maybe this was boys and girls. And perhaps this was phone and no phone. And this diagram had 4 different options, and you'd sit into one of those. In addition to that, it had some totals. So this here would have been the total boys, the total girls. This here would have been the total people without a phone. This here would have been the total people with a phone. And down the very bottom there, that would have been a grand total. So Venn diagrams are really similar in nature, except we start off with a rectangle. And this rectangle includes all possible events. In addition to this rectangle, you're going to include a circle for each of the variables that you care about. So there's a circle there, there's a circle there. So circle for each variable. The areas of this shape relates to the certain criteria. So let's start off, let's say maybe this circle here, that relates to all of the boys. And let's say this circle here relates to people with a phone. The shaded bit in the middle here, this, in terms of your probability notation, would be someone who is a boy and has a phone. This portion here would be phone only, so that there would probably be a girl and a phone. This portion over here, that would be a boy and no phone, because you can see this area here does not sit within that phone circle. And the area around the outside, all that leftover space, that's people who don't fit in either circle. So that means they are not boys and they do not have phones. So if you think of the 4 areas that result from the Venn diagram, those areas are represented in our two-way table. So the first group, boys without a phone, we've identified that. So that's over there. We then looked at girls with a phone. That was represented by this portion of the diagram here. We then had boys without phones. That's represented over here on the left. And finally, we had girls without phones. And that's represented there on the right. So all the information in the Venn diagram does get included into a two-way table. I should note the two-way table does have the added advantage. It's got the totals along the bottom and on the right. And sometimes that information is very useful. At this stage here, I'm going to pause the video. I'm going to clear some of the working and some of the explanations we got, and we get into some questions so you can see this in action. Diagram here on the left, and you'll see some squares, some triangles, you'll see some red stuff and some green stuff. And what I'm going to do is I'm going to think about the 2 variables that I'm going to measure, and there is a bit of discretion here, but I'm going to measure, is a shape square and then or not, so that there would be S or S dash, and is the shape red or not, and that there would be red or red dash. So I'm going to draw my Venn diagram. So there's my rectangle, and I'm going to draw circle number 1, and I'm going to say this circle here would be all the squares, and then finally I'm going to draw a second circle over here, and this diagram would be all the red things. And what we're going to do is we're going to think about all the spaces. So let's think about this middle space here. That is going to represent things that are squares and red. So it's got to have both of those criteria. And when you look at our diagram, which ones are squares in red? We've got those 4 things down the bottom. So that means a 4 would sit in the middle here. We're then going to look at this space over here, and just going down from this, this would represent things that are not a square, because this area falls outside of the square circle, and it would be red because it falls inside the red circle. So we've got not squares and red, and that would only relate to that red triangle. So the triangle is not a square and it's red. So we've got one thing that sits over here. This next portion over here, this relates to squares and not red. And in this case, we've got one square that is green. So that one green square represents this area here. And finally, the outside area, that represents things that are not squares and things that are not red. And in this case, that is represented by the 2 green triangles. So I'm going to draw a 2 on the outside of our shape. Diagram, I've now got a small selection of questions that I want us to start thinking about. So the question asks us to calculate the probability of a randomly selected shape being red. So the first thing we need to start off with is our notation. So the probability of being red, that's equal F over T. We're now thinking fractions, and I encourage you always to start off with the total. So how many shapes are there in total? We could look at the diagram, but I don't want us to do that. The number of shapes relate to the 4 components of our Venn diagram. So I've circled them all there in blue. 1 plus 1 is 2, plus 2 is 4, plus the 4 in the middle gets us to 8. So there's 8 shapes in total, and that matches the diagram we had. How many of them are red? The red one relates to this one guy over here, plus the 4 in the middle. And you can see all of those sit within that red circle. So that means the probability of something being red is 5 over 8. And if you converted that to a decimal, that would be 0.6125. We're now going to move on. The probability of something that isn't a square. So probability of not a square, so S dash, again, it's equal to F over T. We know that the total is 8 because we could have picked any of these shapes. And which ones relate to not a square? So what I'm going to do is I'm going to find the square circle. That's this blue one here. And the not squares are everything outside the circle. So it's going to be that 1, and it's also going to be that 2. So that means the probability of not a square is going to be 3 in 8. And converting that to a decimal, 0.35. And I should note, just realized I've done a math error up here. That should be 0.625, shouldn't it? And the final question, what is the probability of getting something that's red given it's a square? So this one here, it's going to be the probability of red given it's a square. That's my notation. Same process, that's going to be F over T. And the first thing I'm going to start off with is my total, because that's going to be a little bit different here. We know our shape is a square. It's not just any old shape. Maybe we put our hand in the bag and we can feel it's a square. We need to think how many squares are there. So we're going to find the square circle. We're only interested in these 5 squares here. So that means our denominator will be 5. Of these 5, how many are red? And you'll see the red circle over here. So the red squares would fit just in the middle there. This one circle here, that was the non-red. So that there would be 4, and converting that to a probability of 0.8. So hopefully you found this video on Venn diagrams useful. If you do know who that guy is up the top there, maybe comment, just be curious to see who knows it.